Financial Modeling, Topic 19, Stock Valuation, Section 2, Value Stocks using the Dividend Discount Model, also called the DDM. So the Dividend Discount Model states that the value of a stock is simply the present value of all expected dividends. And the most common assumption is those dividends will go into perpetuity. In other words, they'll never end. So the value of a stock today is the sum of the present value of all dividends. Now, normally when we do the present value of dividends, we're going to do a little shortcut. And there's 3 shortcut formulas we're going to use. And it all comes down to what is the expected growth of the dividend. So let's take a stock that's paying, say, a dividend, expected to pay a dividend of $1 next year. If we assume that that $1 is fixed, the dividend will never grow. The dividend per share will never grow. We'll say the growth rate of dividends is going to be 0, and the present value of a no growth perpetuity is simply that dividend received next year divided by the discount rate, where that discount rate reflects the risk of that cash flow. Or you can think of that discount rate as the rate of return that the shareholder demands for that stock. So we'll just simply take the dividend over R. Now that dividend is going to grow at a constant rate. I'll just take the present value of a dividend growing at a constant rate as I'll take that dividend 1 year from now and divide by R minus G, where G is that infinite growth rate of the dividend. The last formula says we're going to forecast dividends at kind of a high rate of growth over the next, say, T years. Little t years. And what we're going to do is we're going to take the present value of all those individual dividends. However, at some point, I'm going to assume that the dividends grow at a constant rate. So maybe 5 or 10 years from now, I'll assume the dividends grow at a constant rate. So I'll take that last dividend, divide it by R minus the constant growth rate into perpetuity, and I have to discount that back to the present. And if that dividend is that one dividend that's going to be growing forever starts at T plus 1 period, you'll discount back to 1 plus R to the T period, since the perpetuity formula always gives you the value of the perpetuity 1 year before, or 1 period before the first cash flow. So let's look at Walmart. Walmart, at the time of this analysis, was trading for $109. And it was about to pay a dividend of $2.12 next year. So let's assume that's an analyst estimate of $2.12 per share 1 year from today. And let's assume that we demand a 6% return for Walmart. So as a shareholder, I want to get a 6% return. It's a relatively safe stock. And also I have some analysis here that says the long-term growth rate of earnings based on analyst estimates is 3.69%. And what I'm going to do is I'm going to value the stock using 0 growth and a constant growth model, and then we'll have this other model that's a hybrid. So let's first value the stock assuming 0 growth. And all I did is I just put it over here. If I demand a 6% return for Walmart and it's going to pay me $2.12 starting 1 year from now and pay me that forever, I'll just take that $2.12 divided by 6%, and Walmart intrinsic value, or the value of all expected cash flows, is going to be $35.33. That's far below the 109. However, let's assume that Walmart is going to grow at 3.69% forever. Remember, that's the analyst estimate for the next 5 years growth. So if I assume that the dividend 1 year from now is $2.12, and then that dividend is going to grow at 3.69 each year for the end of time, what I'm going to do is I'm going to take my $2.12 and I'm going to divide by my discount rate, divide it by R minus my constant growth rate, and I get 91.77. So we can go to the spreadsheet and just do this real quick. So for my constant growth model, I'm just going to take my dividend over R minus G. And there it's worth $91.77, a little bit short of my 109. However, you can't assume that a stock can pay a dividend at such a high rate forever. Now, at the time of this analysis, the long-term treasuries are about 2.4%. Now, that 2.4, or the yield on long-term treasuries, you can think of that as maybe an estimate of the long-term nominal growth of the economy. So you can never have a situation where an individual cash flow for a company grows faster than the economy forever, because that assumes at some point that stock is larger than the economy. So what I'm going to do, I'm going to use a little bit different model. I'm going to assume that it grows at 3.6%, 3.69% for the next 5 years. However, at some point, we're going to have it grow at 2.4% into perpetuity for cash flows from year 6 to infinity. So in other words, I'm going to grow it at 3.69% for the first 5 years, and then I'm going to grow it at 2.4%, the overall growth of the economy, from year 6 to infinity. So we're going to go to our model and do that. Now the dividend is expected to be paid of $2.12. That dividend, we'll assume it grows at 3.69%. And that'll continue through year 5. Whoops. Let's take that dividend and grow it at 1 plus the growth rate. I'll copy that down. So my dividends are going to go from 212 to 251 for years 1 through 6. And then I'll make an assumption. Looks like I made an assumption actually the next 5 years would be years 2 through 6 will grow. 2 through 5 will grow at 3.69%. And then starting in year 6, I'm going to grow it at 2.4%. And then it's going to grow at 2.4% forever. So again, the dividends are going from 212 to 251 from year 1 through 6 years from today. Then I'll take the present value of those dividends. Dividend over 1 plus my discount rate, I'll anchor that, raised to the 1 power and through the 6 power. So if I add up these numbers, it looks like if I just read down here, the sum is $11. If Walmart lasted for only 6 more years, I'd only pay $11 per share. However, we're going to assume that Walmart lasts forever. So here's what I want to do. I want to estimate year 7 dividend. That's going to be the year 6 dividend times 1 plus the perpetual growth rate. Okay, now that is right now, that is my year 7 dividend. I'll take that year 7 dividend and divide by R minus G. Discount rate minus my perpetual growth rate. So again, this is year 7 dividend, because it's year 6 times 1 plus my perpetual growth rate, divided by R minus G. Now this now is a perpetuity. This is the value of the dividends from year 7 till infinity. However, when you apply a growth perpetuity formula, divide by R minus G, it always gives you the value in the period before that cash flow, before the numerator cash flow. So this is a year 7 cash flow over R minus G. So if I just hit enter, that's going to give me the value in year 6. However, everything has to go back to the present value. So I'm going to take that value and discount it back 6 more years by taking 1.06 to the 6 power. I'll then add up all these cash flows and I get 6166. So if I assume that Walmart pays $2.12 1 year from now, whoops, let's go back. If it pays $2.12 1 year from now, that grows at 3.69% and then 2.4% and then 2.4% forever. The present value of those cash flows from year 1 through 6 and then 7 through infinity, I would pay $61.66 for Walmart if the relevant cash flow is dividend. So in this topic, in section 2, we valued stocks using the dividend discount model.